Welcome to Ericaek Journal, where we explore the wonders and mysteries of the cosmos. Today, we're diving into a hypothetical scenario that might keep you awake at night. What if a black hole paid a visit to our solar system? A black hole, a region of space-time where gravity is so strong that nothing, not even light, can escape. Entering our solar system would have profound and far-reaching effects. The specific consequences would depend on a number of factors, primarily the black hole's mass, and how close it gets to us. A small black hole passing at a distance might only cause minor orbital perturbations, while a supermassive black hole passing through the inner solar system would spell utter chaos and destruction. So let's unpack this cosmic what-if and explore the potential scenarios, from the mildly disruptive to the utterly catastrophic. Buckle up, it's going to be a mind-bending ride. Gravity, as we know, is the fundamental force governing the ballet of celestial bodies. It's what keeps planets neatly orbiting stars, moons circling planets, and our solar system as a whole revolving around the galactic center. Now, introduce a black hole into the mix, an object with gravity so intense it warps the fabric of space-time itself, and things get interesting. A black hole wandering into our solar system wouldn't play nice with the established gravitational order. Even from a considerable distance, its gravitational influence could tug on planets, moons, and asteroids, altering their orbits in subtle or dramatic ways. Think of it like adding a hefty new weight to one side of a finely balanced mobile. The closer the black hole, the more pronounced the orbital disruptions. Imagine Neptune's orbit getting elongated, sending it on a wild elliptical journey around the sun. Or perhaps Uranus gets completely ejected from the solar system, flung out into interstellar space like a cosmic frisbee. Inner planets, including Earth, wouldn't be immune. Our orbit could become more eccentric, leading to extreme temperature swings and rendering our planet uninhabitable. In a truly catastrophic scenario, a close encounter with a black hole could send Earth spiraling into the sun, a fiery end to our planetary story. Now, the extent of the orbital mayhem depends heavily on the black hole's mass. A stellar mass black hole, a few times the mass of our sun, would have a significant regional effect. But a supermassive black hole, millions or even billions of times the mass of our sun, could rearrange the entire solar system from a considerable distance. Think of it this way: if our solar system were a pond, a stellar mass black hole would be like dropping a large rock into it, creating ripples and disturbing the nearby lily pads. A supermassive black hole, on the other hand, would be like dropping a mountain into the pond, triggering a tsunami that would reshape the entire landscape. And let's not forget the asteroid belt. A black hole's gravity could stir up this collection of space rocks, sending them hurtling towards the inner planets like a cosmic shotgun blast. Suddenly, we'd have a lot more to worry about than just orbital changes. The gravitational dance between a black hole and our solar system would be a complex and chaotic affair, with potentially devastating consequences. It's a reminder of the delicate balance of our cosmic neighborhood and the immense power of black holes. We've talked about the large-scale gravitational effects of a black hole on our solar system, but what about the up-close and personal experience? Let's just say it wouldn't be pretty. One of the most bizarre and terrifying effects of a black hole's intense gravity is a phenomenon known as spaghettification. Imagine approaching a black hole feet first. The gravity at your feet would be significantly stronger than the gravity at your head. This difference in gravitational pull would stretch you out vertically, like pulling taffy. As you get closer, the difference in gravity becomes more extreme, stretching you further and further. The term spaghettification is quite apt, as you would literally be stretched into a long, thin strand, like a cosmic spaghetti noodle. This wouldn't be a pleasant experience, to say the least. Your bones, muscles, and organs would be ripped apart by the relentless tidal forces. Now, this isn't just a theoretical concept. Spaghettification is a real consequence of the extreme curvature of space-time near a black hole. Any object that gets too close to the black hole's event horizon, the point of no return, would be subject to these tidal forces. Planets aren't immune to spaghettification either. If a planet ventured too close to a black hole, it wouldn't simply be swallowed whole. It would first be stretched and distorted, its spherical shape warped into an elongated ellipsoid. Eventually, the tidal forces would overcome the planet's internal gravity, tearing it apart into a stream of debris. Imagine Earth, our beautiful blue marble, being stretched and contorted like a piece of cosmic Play-Doh. Continents would crack, oceans would boil, and the atmosphere would be ripped away. The planet would eventually be reduced to a swirling stream of atoms, spiraling into the black hole's abyss. The closer an object gets to the black hole, the more extreme the tidal forces become. At the event horizon itself, the tidal forces become infinite, meaning that anything crossing the horizon would be completely and utterly torn apart. So, while the idea of a black hole visit might sound intriguing from a distance, a close encounter would be a decidedly one-sided affair, ending in a rather messy and unpleasant demise. Let's just hope we maintain a safe cosmic distance from these gravitational behemoths. Chapter 3. Accretion and Radiation, a Cosmic Furnace. Black holes aren't just cosmic vacuum cleaners sucking up everything in their path, they're also incredibly messy eaters. As matter spirals towards a black hole, it doesn't simply disappear into the abyss. Instead, it forms a swirling disk of superheated material known as an accretion disk. Think of it like water swirling down a drain, but, on a cosmic scale and with much higher stakes. As material in the accretion disk spirals inwards, it rubs against itself, generating immense friction and heat. This heat causes the disk to glow brightly, emitting intense radiation across the electromagnetic spectrum, from radio waves to gamma rays. The closer the material gets to the black hole, the hotter it gets. Temperatures in the inner regions of an accretion disk can reach millions of degrees, hotter than the core of our sun. This intense heat generates a torrent of X-rays, which can be detected by telescopes even from across vast cosmic distances. Now, if a black hole entered our solar system and started feeding on nearby asteroids, comets, or even planets, the resulting accretion disk would be a powerful source of radiation. This radiation could pose a serious threat to any life forms in the vicinity. Imagine a black hole passing relatively close to Earth, with an active accretion disk blazing with X-rays. The increased radiation levels could strip away our planet's protective ozone layer, leaving us exposed to harmful ultraviolet radiation from the sun. It could also damage our DNA, leading to mutations and increased risk of cancer. Furthermore, the intense heat from the accretion disk could alter Earth's climate, potentially triggering runaway greenhouse effects or even boiling away our oceans. In essence, a nearby black hole with an active accretion disk could turn our planet into a cosmic microwave oven. The intensity of the radiation emitted by an accretion disk depends on the rate at which the black hole is feeding. A black hole actively consuming a large amount of material would generate a much brighter and more dangerous accretion disk than a black hole that's only snacking on a few stray asteroids. So, while the gravitational effects of a black hole are certainly something to be concerned about, the radiation emitted by its accretion disk could be equally devastating. It's another reminder of the immense power of these cosmic objects and the importance of keeping our distance. Chapter 4. Planetary Destruction, a Cosmic Collision Course. Let's face it, the worst-case scenario of a black hole visit is a direct hit. What happens if a black hole actually collides with a planet? Well, collision isn't quite the right word. It's more like a cosmic tonsure, a one-way trip into oblivion. Remember, a black hole isn't a solid object, it's a region of space-time with an extremely strong gravitational field. So a planet wouldn't bounce off a black hole like a billiard ball. Instead, it would be drawn inexorably towards the event horizon. As the planet approached the black hole, it would experience the tidal forces we discussed earlier, being stretched and distorted into a spaghetti-like stream of matter. This stream would then spiral into the black hole, adding to the mass and size of the black hole itself. The process wouldn't be instantaneous. Depending on the size of the black hole and the planet, it could take hours, days, or even weeks for the planet to be completely consumed. During this time, the planet would be subjected to increasingly intense tidal forces and radiation, a truly agonizing demise. Imagine Earth being drawn towards a black hole. Our continents would crack and crumble, our oceans would boil away, and our atmosphere would be ripped into shreds. The planet would be reduced to a swirling stream of atoms, spiraling into the black hole's insatiable maw. Now, the chances of a direct collision between a black hole and a planet are incredibly slim. Space is vast, and even in a crowded solar system, the odds of two objects colliding are relatively low. However, if a black hole were to wander into our solar system, the gravitational perturbations it would cause could increase the risk of planetary collisions. For example, a black hole could nudge an asteroid or comet onto a collision course with Earth, leading to a devastating impact. Or it could disrupt the orbits of the planets, increasing the chance of a planetary collision. So, while a direct collision with a black hole is a low-probability event, it's still a possibility we shouldn't ignore. The consequences of such a collision would be catastrophic, leading to the complete and utter destruction of a planet. Chapter 5. Cosmic Odds. Just how likely is a black hole visit? We've explored the potential consequences of a black hole entering our solar system, from orbital disruptions to planetary annihilation. But how likely is such a scenario? Should we be losing sleep over the prospect of a cosmic visitor crashing our planetary party? The short answer is, probably not. The vastness of space makes the probability of a black hole encountering our solar system exceedingly slim. Think of it this way. Our solar system is a tiny speck of dust in the vast cosmic ocean, and black holes, while powerful, are relatively rare objects. To put it in perspective, the closest known black hole to Earth is V616 Monocerotis, located about 3,000 light-years away. That's a comfortable distance, cosmically speaking. And while there are undoubtedly many more black holes out there that we haven't detected, the odds of one wandering into our solar system are extremely low. Astronomers are constantly scanning the skies, searching for near-Earth objects, including asteroids, comets, and potentially even black holes. So far, they haven't identified any black holes on a collision course with us. That said, just because something is unlikely doesn't mean it's impossible. The universe is full of surprises, and we can't rule out the possibility of a rogue black hole wandering into our cosmic neighborhood someday. But even if a black hole did approach our solar system, it's not necessarily a guaranteed doomsday scenario. The effects of a black hole encounter would depend on its mass, trajectory, and proximity to us. A small black hole passing at a safe distance might only cause minor orbital perturbations, while a larger black hole passing closer could have more severe consequences. So, should we be worried? Probably not. But it's always good to be prepared. By studying black holes and understanding their properties, we can better assess the risks they pose and potentially even develop strategies to mitigate those risks. The universe is a vast and mysterious place, and while it holds potential dangers, it also holds boundless wonders. By exploring the cosmos and unraveling its secrets, we can gain a deeper appreciation for our place in the universe and prepare ourselves for whatever the future may hold. In summary, while the theoretical consequences of a black hole entering our solar system are indeed catastrophic, ranging from orbital disruptions to complete planetary annihilation, the probability of such an event occurring is extremely low. The vastness of space acts as a buffer, making a close encounter with a black hole a highly improbable event. However, this thought experiment serves as a powerful reminder of the immense forces at play in the universe and the delicate balance that sustains our solar system. It underscores the importance of continued astronomical research, allowing us to better understand these celestial behemoths and any potential risks they may pose. So, while a black hole visit might be a fascinating thought experiment, we can rest relatively assured that our cosmic neighborhood is safe, at least for the foreseeable future. Keep looking up, keep exploring, and keep wondering about the universe and its many mysteries.